Hello learners, again I am Priyanka Gupta, working as assistant professor in Department of Computer Science and Engineering, Data Science Department of Institute of Aeronautical Engineering, Hyderabad. So we have completed our first module of the introduction of data mining. The subject data mining, we have covered first topic, first of the module, introduction to data mining. Now we are coming into the second module of the program. So second module is association mining rules. So today we are going to cover the contents are basic concept of association root mining, a priori algorithm, different data formats for mining, mining with multiple minimum support, mining class association rules, and the summary of all the rules. Let's start. So what is association rule mining? That is the data mining rule. That is the rule when mean for data mining. That is what it is doing. It is only doing. It is giving the confidence and support to purchase any type of product for the customer analysis. It is going to use for prediction. So we'll see the history of the association rule mining. That association rule mining is proposed by Agrawal et al. In 1993. It is an important data mining model studied extensively by the database and data mining community. Assume all the data is categorical, that only we are going to use association rule mining. Only for categorical type of data. No good algorithm for numeric data. So there is no any better rule for to fetch data mining only for numeric data. Initially, it is used for market basket analysis to find how items purchased by the customers are related. How the related items which is going to purchase by the customers are related to each other. So initially it is used for market basket analysis. What is market basket analysis? Let's see. Market basket analysis. First, the association rule mining is called as market basket analysis. That is also for the purchasing of the products by the customers, which are the items are related to each other. Items related to each other. So market basket. So let's see an example. In any retail store, we are going to purchase for milk. We are going to purchase milk. There is also option for the bread, butter, eggs, milk. So these are the dependent items for while we are going to purchase milk. So this is the related product we are going to purchase while as a customer while we are entering into any shopping store. So here bread is dependent on the milk. Bread is dependent on the milk. So here if there is a calculation, if we will calculate the support of the material, support of the bread towards milk, it will be 5%. And while we are going to calculate the confidence of the item, that will be the 100%. Confidence is directly related to the product we are going to purchase. So surely when we are going to purchase milk, we will also purchase bread. That is a prediction. That is a prediction. And for doing that, we are applying the association rule mining for the better prediction of the related items. So that is the association rule mining, or we call as market basket analysis. Transactional data support supermarket data. So what is transactional data? As we have seen in earlier slides, earlier course, transactional data is nothing but while some transaction is going to happen, that data only called as transaction data. So here we will take an example of market basket transactions. So in first cart we are having bread, cheese, milk. T1 is equal to bread, cheese, milk. In other cart we are having apple, eggs, salt, yogurt, and so on. In TN cart we are having biscuit, eggs, and milk. So these are the baskets we are having to purchase for a one time by the customer. So what are the concept? An item article in a basket. What is an item in this cart, in basket? An item article in a basket. I. What is I? The set of all items sold in the store. Total items is sold by the store is called as I. Is defined as I. What is a transaction? Transaction is nothing but item purchased in a basket. There is a one basket T1 in which we have purchased bread, cheese, milk. So the transaction is nothing but what are the items we are going to add in our basket from the supermarket, a superstore. What is a transactional data set? Transactional data set. A set of transactions. So this is the transactional data set. This is the transactional data set. Because it is having a set of baskets with the other items. So a set of documents. We'll take an example for a set of document for transaction data only. So the text document, a text document data set, what it is? Each document is treated as a bag. We call this as a bag. Earlier we are taking as a basket, but while we are taking the transaction data for a set of documents, then only we'll call as bag. So this is the example of a bag which is having, for first bag, document 1, it is having student, teach, school. For second document, it is having student and school. For third document, it is having teach, school, city, and game. For fourth of the bag, it is having basketball and baseball. For document 5, it is having basketball, player, and spectator. And for the document 6, bag 6, it is having baseball, coach, game, team. And for document 7, it is having basketball, team, city, and game. So this is a set of bags. This we call as a set of bags. The single basket is called as bag, but a set of basket called as a set of bag. So that was for the document type of data set. So the model, what are the rules we are applying? What are the rules for association mining? So a transaction T contains X. A set of items, item set we call in I if X is a set of T. And association rule is an implication of the form X depends on Y, where X and Y is a set of I and X is a intersection of Y. That is null. So the item set is a set of item. What is item set? Item set is a nothing but a set of items. These are some terms while we are applying a association rule mining. What is k item set? That is a item set with k item. K set of items. That is called the key item set. So, for example, we will take an example for item set. That is, if we are having a basket of X is equal to milk, bread, and cereal. That is an item set. Now we are having a bunch of items, like if we are having example of milk, bread, cereal is a 3-item set. That is a k items. 1, 2, 3. 1, 2, 3. So that we call as a item set. Rule strength when we measure that. So we will see what is support. Support is nothing but the rule that holds with support SUP in T, the transactional data set, if support percentage of transaction contains X union Y. Support is nothing but the X union Y of support. What is confidence? Confidence is the nothing but the rule that holds in T which confidence, if confidence percentage of transactions that contains X also contains Y. In that, X also contains Y. Here, X is also containing Y. So, an association rule mining is a pattern that states when X occurs, Y occurs with certain probability. So, there will be the probability if X is also occurring and Y is also occurring. X is also occurring and Y is also occurring. Then only there will be the association rule we can apply. Association rule we can apply. So, what is support formula? Support of any product is equal to number of transactions includes that product divided by total number of transactions. So, while we are calculating the formula support for any product, so we have to check the number of transactions that include that product also, while which we are going to purchase divided by total numbers of transactions. How many transactions we are having? We will divide by that. What will be the confidence of that product? The confidence will be that product is number of transactions include both of the items we are going to purchase or not going to purchase, A and B, divided by number of transactions that include only first item which we are going to purchase. So before applying association rule mining, we have to calculate the support of the product and confidence of the product. So support and confidence. Support count. How we are going to count that? The support count of an item set X denoted by X dot count. In a data set, T is the number of transactions in T that contains X. Assume T has n transactions. Then what will be the formula? Support is equal to X union Y dot count upon n. For confidence, X union Y dot count upon X dot count. So, what are the goals and key features for the association rule mining? Association rule mining. The goal is to find all rules that satisfy the user specified minimum support and minimum confidence. We have to calculate the minimum support for the item, and we have to also calculate the minimum confidence for the item while we are going to purchase that item from the particular store. So what are the key features behind that? We need to check we need to check for completeness, where we have to find the all rules which are going to apply for the association rule 1. We have to take no target items on the right hand side. There will be only the transactional type of data from on the right hand side. Again, we have to mine that data on the hard disk. We are not going to store that in a memory. We have to store that all data in the hard disk. So that was the goal and features for the association rule mining. So, for example, if you are having some type of transaction data the basket is containing in T1 basket we are having beef, chicken and milk. The basket 2 we are having beef and cheese. In basket 3 cheese and boots. In basket 4 we are having beef, chicken and cheese. In basket 5 we are having beef, chicken, cloths, cheese and milk. In basket 6 we are having chicken, cloths and milk. In basket 7 we are having chicken, milk and cloths. So this is a bag of baskets, set of baskets we are having as a transaction data. So we have to assume if the minimum support is the 30% for the purchase any type of product and the minimum confidence is 80%. So for example, we have to calculate the frequent item set. What will be the frequent item set? In this, we will check which are the items is occurred frequently in these baskets. So we'll check one by one. So here we can see in the bag 1, beef is there. In bag 2, beef is there. That is repeated. In the bag 3, we are having cheese. In bag 2, we are also having cheese. So these are two related. In bag 4, we are having beef. That third time the beef has occurred. So in the fourth basket, we are having cheese. So this is occurring for third time, as it is occurred in second basket, third basket, and fourth basket. Again, we are having the beef for the fourth time in the bag 5. So we'll also check for cheese in this bag. Chicken, cloth, cheese. Cheese is again occurred. That is the fourth occurrence of the cheese item. In the bag 6, we will check for either beef and cloth and cheese is occurring or not. That is not there. In bag 7, we will check for the both of the items if it is occurring or not. That is not there. So we can see the beef item that is occurred for 4 times, the cheese that is occurred for 4 times, and we will also check for chicken is also there, that is occurred few more times. So we can check in bag 1 chicken is there, in bag 4 chicken is there, bag 5 chicken is there, bag 6 and 7 chicken is there. So the chicken, that item that occurred for 5 times. So like this we need to calculate the how many times the items has been occurred in the basket. Rather than then we will check for the other items also. Milk is there. Milk is also in 5th basket, 6th and 7th basket. So milk is also occurred for the 4 time. Milk is occurred for 4 time. So again we will check for other items. We have escaped like boots. Boots is not there in any other basket. We can see. We will check for the cloth. Cloth is in 5th basket and 6th basket. So cloth that is occurred for 2 times. So these are the all transaction data with this set of baskets. So we will check for the frequent item set. What are the frequent item set in there? Chicken, cheese and milk. And we can also say beef. So we will take the 3 items as example: cheese, chicken and milk. So the support for the cheese, chicken and milk is 3 upon total transaction. How many transactions are occurring? 1, 2, 3, 4, 5, 6, 7. So T1, T2, T3 to T7 is nothing but the transaction of the items. So that will be the support will be the 3 upon 7. 3 upon 7. So association rules from these item set. What will be the association rules? Cloths. Cloths is dependent on milk and chicken. Milk and chicken. Milk and chicken. So in the transaction 5 and 6, we can check these. This is occurring. So what will be the support for this? What will be the support for the items? So we will check one by one. We will check one by one. So the support will be the for the milk and chicken will be the 3 upon 7. How many times milk is occurring? 4. How many times chicken is occurring? 4. But for the cloth, which is in the transaction 5 and 6, so that cheese, milk and chicken, that is occurring by 3 times, that is divided by 7. No, it is also in 5, 6, 7. 5, 6, 7. 3 transactions it is taking. T5, T6 and T7. So what will be the support for that? 3 by 7. What will be the confidence for that? Confidence for that? 3 by 3. 3 by 3. So 3 is the first item and second item both occurred how many times? Divided by the first item occurred how many times? That is the divided by that. So then confidence will be the 100% and the support will be the 3 by 7 percentage. And so on. The cloths and chicken, both of the items dependent on the milk. So for that support will be the 3 upon 7 and for that confidence will be the 3 by 3 means that will be the 100%. So when we will purchase the cloth and chicken, we will surely we are going to purchase milk. So that was the association rule for these item sets. Many mining algorithm. More than that, many algorithm are there. There are a large number of them, but what we are using? We are using some of them. They use different strategy and data structure. Obviously, the more rules are there, the more strategy there will be. So that also will be used different type of data structures. So their resulting set of rules that will be the same. Why? Because given a transaction data set T and a minimum support and a minimum confidence, a set of association rule existing in T is uniquely defined. Because of that only, we will have set the rules for same. The rules will be same for all. Any algorithm should find the same set of rules, although their computational efficiency and memory requirements may be different. We study only one. In this module, we are going to apply the a priori algorithm. So let's discuss. The a priori algorithm. What is that? This is probably the best known algorithm. The best known algorithm for association rule mining. So we will take 2 steps for that. We are having 2 steps for that. The first step, we have to find all item sets that has the minimum support, frequent item set, we also call as, and also we call as larger item set. We have to use frequent item set to generate some of the rules. This is the second step of the while we are going to apply a priori algorithm. So we will take an example for that. For example, if we are having a frequent item set of some items, like we are having chicken, cloth and milk, so support will be this for this transaction 3 by 7. And apart from that, we also have to recognize, we also have to take one rule for that. One rule from the this item set will be the cloth will be dependent on milk and chicken. Either milk, either on chicken. So what will be the support for that? The support will be for that is 3 by 7, because the cloth is occurring 3 times while we are having in bag milk and chicken, and divided by total item sets, total transactions, total transactions. So what will be the confidence for that? Again, this will be the only 3 by 3, because it is the both of the items together having the cloth 3 times, that is divided by the first item occurring in the different transactions. So the first step we are taking as mining all the frequent items. So what it will be? We have to take a frequent item set is an item set that are having support is greater than or equal to minimum support. Their support will be the greater than the minimum support of the items. So what is the key idea behind that? The a priori property, downward closure property, any subset of a frequent item set are also frequent item sets. A subset of frequent item set are also we are calling as frequent item sets. So this is the downward closure property of the item sets. We can see in this example, in this graph. So what it is taking? There are some items ABC, ABD, ACD, BCD. These are some transactions having the frequent item sets, while this is the item set frequently occurring from that A, B, C, D. So the algorithm, the iterative algorithm is also called as level-wise search. So in that, what we need to find? We need to find the one item set, frequent item set, then all the 2 item set, and so on. We have to first have to find one item set, then we have to find 2 item set, and then so on, 3 item set, like that. So in each iteration of k, only consider item set that contains only k minus 1 frequent items. K minus 1 frequent item sets. So we need to find frequent item set of size 1, that is called as F1, from k is equal to 2. In that ck is equal to candidate of size k, those item sets of size k that could be frequent given fk minus 1. Fk, what is Fk in that? Fk is those item set that are actually frequent. Fk is need to scan the database once. So for example, finding frequent item set in this transaction, in this item set data set, we are having some transaction, 4 transaction, that is nothing but T100, T200, T300 and T400. These are the transaction IDs for these data sets. And for related items are that for T100 transaction we are having 134, T200 transaction we are having 235, and so on. So minimum support for this these are the data set will be the 0.5. So in first step we need to scan T that is having 1, 2, 2, 3, 3, 3, 4, 1 and 5, 3. In a second step, we need to find frequent item set, that is 1, 2, 2, 3, 3, 3 and 5, 3. In the for the confidence for the candidate, we are having candidate item set 1, 2, 1, 3, 1, 5, 2, 3, 2, 5, 3, 5. For the second scan T, we will check like same like that only. So we will get the 3 item set of 2, 3, 5. In this, we are calculating the 1 item set, 2 item set. So for the transaction 3, we have to calculate the final 3 item set, that is having the all transactions of the item set. So what will be the final item set? 2, 3 and 5. So this was the frequent item set. While we are going to choose how we are going to transact these data from the data set, that were the some steps. We need to do this again and again for the different transactions. So in detail, ordering of items is nothing but the item in I are sorted in lexicographic order, which is a total number. The order is used throughout the algorithm in each item set. So here W1, W2 to WK, that represents a K item set. In this W consisting of items W1, W2 to WK, where W1 is less than W2 is less than WK according to the total order. So what will be the algorithm behind that? What will be the a priori algorithm? This is written over here. So that is the whole of the set of steps we are concluding for the a priori algorithm. A priori candidate generation. The candidate generation function fk-1 and returns a superset called the candidate of set of all frequent k item sets. It has the 2 steps. While we are doing that, we are having 2 steps, join step and prune step. We have to join the candidate item sets, and then we have to remove those candidate item sets that are not occurring frequently. So in join item set, what we need to do? We need to generate all the possible candidate item sets ck of length k. For the pruning step, we are going to remove those candidate sets in ck that cannot be repeated, they cannot be frequent. So this is the algorithm for candidate generation function. What is the function? fk-1. So this is the whole algorithm in which all the steps are going on while we are joining, while we are pruning, and so on. And again we are repeating the same. For example, in a data set we are F3, we are having 3 item sets item that is containing 1, 2, 3, 1, 2, 4, 1, 3, 5, 1, 3, 5, 2, 3, 4. So we have to join this in another step. Then it will be the 1, 2, 3, 4 that is occurring regularly. 1, 2, 1, 2, here 1, 2, here 1, 1, 1, 1. First we will check for 1. 1 is not there. We will remove that. 2, 2, 2. 3, 3, 3, 3. 3 is also there. 4. 4 is there, and there. So after joining these 2, we will have the item set, 4 item set of 2 items like 1, 2, 3, 4 and 1, 3, 4, 5. That are the frequent item sets. So after that, we have to remove, we need to prune that item sets as a 1 item set. So what we will have after pruning? We will have 1, 2, 3, 4 item set, which is not frequent. That is not occurring frequent because 1, 4, 5 is not in F3. Because 1, 4, 5 is not here. We can check 1, 3, 4 is not here. So we are taking 1, 2, 3, 4 apart from 1, 4, 1, 3, 4, 5. So that will remove, that we will going to prune in candidate function. So what is the second step to doing that? We have to generate rules from the frequent item sets. Frequent item set is not equal to association rules. In that, one more step is needed to generate association rule. For each frequent item set X, for each proper non-empty subset A of X, let consider B is equal to X minus 1, X minus A, X minus A. So, in second step, A is depends on B is an association rule if the confidence A depends on B is greater than or equal to minimum confidence, and then support of A depends on B is equal to support of A union B, that is also equal to support of X. Like this, we also need to calculate the confidence for the same. So these were the second step for generating some of the rules while we are having frequent item set in the data set. So for example, if we are having suppose 2, 3, 4, that is a frequent with support 50%, then proper non-empty subset will be 2, 3, 2, 4, 3, 4, 2, 3 and 4. With the support, minimum support 50%, 50%, 75%, 75%, 75%, 75% for each. We need to calculate from that formula we have checked in earlier slides. So for each we need to calculate. For 2, 3 we need to calculate that confidence and support. For 2, 3 we also have to calculate, and so on. For the 4 we also need to calculate. So we will get these of the confidence support like 50%, 50%, 50, 75, 75 and 75 respectively. So these generated association rules will be the 2 and 3 will be 2 and 3 depends on the 4. So we will calculate the confidence for that. The confidence for that will be the 100%. We will get the one that will be the 100%. So for 2 and 4 item set, that will be 100% only. 3 and 4, that depends on 2, that will be the 6-7%. For 2, that depends on 2, 3 and 4. So their confidence will be the 67%. 3 depends on 2 and 4. So confidence will be for that also 67%, same as earlier. For 4, 67%. So all the rules have the support 50% for these items. The confidence will be the support will be the 50%. Confidence we are calculated for each item set, and the support for all will be the 50% only. So that was the example of the second step. So this, in summary, we have checked the order to obtain A depends on B. For that, we need to support A union B and support A. All the required information for confidence computation has already been recorded in the item set generation. No need to see the data transaction anymore. We again and again, we don't need to see the data transaction. So this step is not as time consuming as frequent item set generation. So on a priori algorithm, we need to seems to be very, very expensive. When level-wise search will be there, k is equal to the size of the larger item set will be there. It makes at most k passes over the data. That in practice, k is bounded by 10, and the algorithm is very, very fast. We can check, and under the sum only conditions, the all rules can be found in linear time. For the sum of the rules only, that can be found for linearly. After that, we can scale up that as a larger data sets also. So this was all we can apply on a priori algorithm. So more on the association rule mining, we need to clearly check the space for all association rules, that is exponentially 2 to the power m, where m is the number of items in the I. The mining exploits spareness of data, and the high minimum support and high minimum confidence value. Still, it always produces a huge number of rules, thousands and sometimes 10 of thousands and sometimes million rules. So that was more on the association rule mining rules. So different data formats for mining. These are the different data items, formats for the data mining. What are that? The data can be transaction form or table form. The transaction form will be the AB, ACDE, ADF. And when we will have table form, then the attribute 1, 2, 3, and that will be the record A, B, D, B, C, E for the each of the columns. So the table data need to be converted to transactions form for association rule mining. If we are having some type of table data, we need to convert that in a transaction. We need to convert that in a transaction. Then only we will apply the association rule mining one by one, step by step. So from a table to a set of transaction, how we are going to change that? How we need to change that? This is a table form. The transaction will be the attribute 1, comma A, that will be the first item set. Attribute 2, comma B, that will be the second. Attribute 3, D, and for the second record, it will be the attribute 1B, attribute 2C, attribute 3E. So like this, we need to convert that table data in a transaction. In these transactions, these are the some transactions. So the candidate generation can be slightly improved. Why? So that is a question. So problems with the association rule mining, some of the problem also can occur. That is single minimum support. It assumes that all the items in the data are of the same nature and or have the similar frequency. Then the only single minimum support can occur. So that is the problem we are having the some of the data set. That can be not true when in many applications some items appear very frequently in that data. Means each of the transaction, if the data have frequently occurring and while others rarely appearing, so that will also be the hard to make a association rule, because how that can be dependent on the other. So for example, if we are taking a supermarket data, the people who buy food processor and cooking pan much less frequently than they buy bread and milk. So how they are associated with each other, how they are dependent on each other, that is a question mark. So that is sometimes not true. So rare item problems, what it can be, if the frequency of the item vary a great deal, we will encounter two of the problems. The first problem is if the minimum support is set too high, those of the rules, those of the association rules that involves rare items will not be found. So when we have the support is very high, support should be less only. If we will have that in a term of very high, so that we cannot have the item in the transaction. There will be the rare transaction of that item. Second problem that can be to find that rules that involve both frequent and rare items that has the minimum support to set very low. That was the very high, that that will be the very low. So this may cause the combinational explosion, because those of the frequent items will be associated with one another with all possible way. So that of the frequent items can be associated with one another, each of one in all the possible way. So that will be the not will be the that good association rule mining. So these are the some problems we have to encounter while we are going to make some rules for that. multiple minimum support model. So the minimum support of a rule is expressed in terms of minimum item support MIS of the items that appear in the rule. Each item can have a minimum item support. So each item can have a minimum item support. So by providing these different minimum item support value for different items, the user effectively express different support requirement for different rules. So there will be the different support for the each another rule. So there will be different rules for that if we have the minimum item support. So, for example, consider the following items if you are having in a transaction: bread, shoes, and clothes. So, the user specified minimum item support value will be the minimum support value for the bread will be 2%, for shoes 0.1%, for clothes 0.2%. So, the following rules does not satisfy its minimum support. If the cloth that depends on the bread, if in a transaction the cloth it depends on bread, the support will be for that 0.15%, while we will calculate from the formula, and the confidence will be for that 70% for this transaction, while cloth depends on bread. So that does not satisfy for the minimum support. That is not the minimum support for the item set. So the following rules satisfy its minimum support while we are having cloth dependence on shoes. So the minimum support will be the 0.15% and confidence will be the 70%. For this transaction, for this basket. After that, we need to check the candidate item set generation. So what are the special treatment needed for that? Some of the rules are there. We need to sort the items according to their minimum item support value. So we need to first check the order ascending or descending. We need to sort that. After that, in first pass, over the whole of the data for the first 3 lines, we need to check it is in the same rules. We need to apply that. For the candidate generation at the level 2, we need to apply that only. After that, we will apply the pruning step in the level K, while the K is more than 2, while we are generating the key. So that was all for the candidate item set generation. So for the first pass over data, what we will do, what it does, it makes the pass over the data to record the support count of each item. After that, it then follows the sorted order to find the first item I in M that meets the minimum item support of I. In that, I is inserted into L, and that for each subsequent item J in M after I, if J dot count divided by N is greater than and equal to minimum item support of I, then J is also inserted into L, where J dot I count is the support count of the J and N. That is the total number of transactions in T. After that, that is L is used by function level 2 candidate generation. So that was the first pass over the data. So for example, if we are consider the 4 items 1, 2, 3, 4 in a data set, their minimum item support, if their minimum item support is for first, minimum item support for item 1 will be the 10%, for 2 20%, 5 for 3 5%, and for 4 6%. So we need to assume our data set has 100 transactions. So for the first pass, that gives the following counts. So when we will calculate that, so that will be the 3 dot count, that is equal to 6. 1 dot count, why we will calculate that? It will be the 9. 4 dot count, it will be the 3. 2 dot count, we will get 25. So these were the first pass for the 100 transactions. So for after 100 transactions only, we need to calculate the minimum item support for each of the item, each of the transaction. Then L is equal to 312 and F1 is equal to 3 and 2. So item 4 is not in L because 4 dot count divided by N is less than minimum item support of 3, that is equal to 5%. Again, 1 is not in F1 because 1 dot count divided by N is less than minimum item support of 1, that is 10%. So that was the example of first overpass data. So we have studied everything, every rule about the association rule mining that contain association rule mining that has been actively studied in the data mining community. There are many efficient algorithm and model variations appearing. We have covered a priori algorithm throughout. So other related work includes that we can say multi-level or generalized rule mining, constrained rule mining, incremental rule mining, maximal frequent item set mining, numeric association rule mining, rule interestingness and visualization, parallel algorithm. These are the other rules that also can be used for data mining. So that in this module, we have covered the a priori algorithm. Thank you. Keep watching the data mining subject.
Like, share and subscribe. Hit the bell icon for more updates.